Okay, so next problems 28 through 33. I'll copy that. Researchers want to know if drinking caffeinated drinks improves reaction time. They randomly select volunteers in a blinded experiment, give some of them caffeinated drinks, and others non-caffeinated drinks. Then they record reaction time, and it says group 1, 30 people drank 300 milligrams of caffeine. Their reaction time was this, with a standard deviation of 110. 25 people had 0 milligrams of caffeine. Their reaction time was 640 milliseconds with a standard deviation of 130. Is this evidence that drinking caffeine improves reaction time? Okay, first off, means or proportions, one sample or two? We're dealing with means, okay, because we're looking at average reaction time. And do we have one sample or two samples? Two samples. Okay, and it says we're doing a hypothesis test. Okay, so let's list off the data that we have. We have sample 1, which is that with the caffeine. So what is our size of sample 1? Our N1 is 30, and our X bar is 580, and our S 110. Sample 2 has N what? 25, X bar 640, and S 130. Okay? 30, 580, 110, 25, 640, and 130. Okay? These numbers, 300 milligrams of caffeine and 0 milligrams of caffeine, are just distractor numbers. They're not part of the problem. Okay? When performing a one-sided hypothesis test, what should the hypotheses be? Okay? This one is a little bit tricky. Okay? So the null hypothesis is easy. We're going to write mu1 minus mu2 is equal to what? 0. Okay, that's always going to be our null hypothesis for two samples means hypothesis test. The alternative hypothesis is going to be mu1 minus mu2, and it's either going to be greater than, less than, or not equal to 0. Okay? So we have to read this carefully. It says, is this evidence that drinking caffeine improves reaction time? Okay, so that would imply what? Well, first off, it says one-sided hypothesis test, so we know it's not going to be not equal to. And the question now is, do we use a greater than or a less than sign? Okay, so what does it mean if your reaction time improves? Do you get faster or slower? You get faster, okay? So your reaction time, should that be more or less? It should be less, right? Improved reaction time means it takes you less time to respond. Okay? So that means the people with caffeine, should their numbers be bigger or smaller? Smaller. So we're going to have mu1 minus mu2 less than 0. Okay? For less than, because improves reaction time means the time is faster / less. Okay, so that's a little bit tricky, and there might be something a little bit tricky on the final like that. Okay, just saying, maybe not.
What are the odds?
Who knows? Okay, 29. What is the observed difference in means? Well, that's going to just be x bar 1 minus x bar 2. So I'm going to do 580 minus 640, and I get negative 60 milliseconds, or just negative 60, that's fine. Number 30 asks, what is the resulting T statistic? Okay, so our test statistic T is going to be x bar 1 minus x bar 2 over the standard error. What is our standard error? Well, we have two samples, means, and we can go to the study guide, but I will just tell you what the study guide says. It says this is the standard error in this scenario. S1 squared over N1 plus S2 squared over N2. Okay, so again, always remember to check what situation you have. We've got two samples and we're dealing with means. S1 squared over N1 plus S2 squared over N2. So when we punch in these numbers for the standard error, we have 110 squared over 30 plus 130 squared over 25. And I take the square root, oops, of everything. And I get 32.85. So our T is going to be negative 60 divided by 32.85, and I get negative 1.826. That's my test statistic. (31) What is our p-value? So what do I do now to get my p-value? I look it up, and what table do I look it up in? The T table. So when I use the T table, I got to figure out my degrees of freedom. So how many degrees of freedom do I have? 24, right? So I go to the T table, and my degrees of freedom is n minus 1. And using the smaller n, I get 24 degrees of freedom. So we'll go to the reference table. 24 degrees of freedom. All right, let's see. 24 degrees of freedom, and I'm looking for 1.826. So 1.826 goes right here. So that means the tail area is in between 0.025 and 0.050. Okay? Because 1.826 is in between these two numbers. So my tail area is going to be in between these two numbers. So tail is between 0.025 and the other number is 0.050. Okay? So I didn't put the signs, so now that I see these signs, okay, now I can do the alligator's going to eat that number because it's bigger, and this one's smaller, so it's not going to eat it. All right, so I've got that. What is my p-value? Well, the p-value is my tail area. Okay, I don't need to double it because I have a one-sided test. So my tail area is my p-value. So I'm just going to leave everything as is, and I'm going to say my p-value is between 0.025 and 0.050. And the alligator mouths are still pointing the same way. All right, if our alpha is 0.05, what conclusion do we make? Is my p-value bigger or smaller than 0.05? It's smaller. Right here it says 0.05 or 0.050 is bigger than the p-value. The alligator would rather eat 0.05. So our p-value is less and then 0.05. So do we reject or not reject?
Reject.
So we reject what? The null hypothesis. Okay, that means we have evidence that caffeine improves reaction time. And lastly, if our conclusion was wrong, what kind of error did we make? Type 1 or type 2? Type 1, we rejected the null. That was a type 1 mistake. Come back. I didn't mean to reject you. All right. Is that good? It's not so awful, is it? I guess that's a matter of opinion.
Whose opinion?
Mine, of course. Everybody's entitled to his or her own opinion. My opinion is that this isn't so bad, but of course I would think that. All right, in a certain city, a study was conducted to see if the police department had a different proportion of minority employees than the fire department. Researchers randomly selected 200 employees from both the police and fire departments and took note of whether the employee was a minority or not. Group 1, 200 random police department employees, 80 of them were minorities. Group 2, 200 random fire department employees, 50 of them were minorities. Okay. I wrote this problem years ago, and now it's like a current issue with events around the country. So, let's see. Do we have one sample or two samples? Are we dealing with means or proportions? Okay, we got proportions. And how many samples do we have? Two samples. And we're doing a hypothesis test. So let's look at our data. Sample 1 and sample 2. Sample 1 we'll say will be the police department. How big is the sample from the police department? 200. Okay, 200 total. And how many people were minorities? 80. And in sample 2, we have the fire department. N2 will be 200. And how many minority employees in the fire department? 50. Okay, so let's figure out our p-hats. And p-hat for sample 2. P-hat 1, 80 over 200, what is that? 0.4. P-hat 2, 50 over 200, 0.25. We want to know, is this evidence that the departments are different? Okay. So 34, what are the hypotheses? We have a null hypothesis and an alternative hypothesis. Okay. All right, well, if I go to the study guide, I say, well, I don't know what to do. I've got two samples. Oops. Two samples, and I'm dealing with proportions. So what do? Okay, two sample proportions. The null hypothesis is P1 minus P2 equal to 0. So that's what I'll say. P1 minus P2 equals 0. And then the alternative is going to be P1 minus P2 something greater than, less than, or not equal. Okay, well here it says, is this evidence that the two departments are different? So what do I use? Not equal. And 35 says, what is the value of p-hat? P-hat is going to be x bar 1. I'm sorry, not x bar, just x1 plus x2 over n1 plus n2. So I have 80 plus 50 divided by 200 plus 200. So I have 130 over 400. What is this? 0.325. Perform a hypothesis test. What is the test statistic? Okay, so Z, all right, well, here, we'll just pretend like we don't know what we're doing, so we're going to say, okay, well, what do I do for the test statistic? Okay, so we know we're dealing with two sample proportions, so the observed value is going to be P1 hat minus P2 hat. Okay, that goes observed minus null. For two sample proportions, the null value is 0, and then the standard error for two sample proportions is this crazy thing. Okay, so we'll do that. We'll say P hat 1 minus P hat 2. That's our observed minus the null, which was 0, if we want to put in that. And then we're going to divide by the standard error. And we saw that the standard error is P hat times 1 minus P hat times 1 over N1 plus 1 over N2. So you just copy this. Okay. Is everything so far going okay? All right. Is this study guide helpful? Yes. Okay. So, well, I hope so. That's why I bother making it. To help you. Alright, so I'm just going to plug in all of these numbers. 1 over 200 plus 1 over 200. Take the square root of everything. Can I just tell you what number I get? Alright, instead of actually punching it into the calculator. So I get 0.04684. And so the Z is going to be 0.4 minus 0.25 divided by 0.04684. And I get 3.20. That's my Z-score. So with my Z-score, what do I do to get my p-value? I go to the Z table, right? I go to the Z table. We're going to look up 3.2 positive 3.20, and I find 0.9993. 3.20 gives me 0.9993. Okay? So from the table, Z is equal to 3.2. The area to the left is equal to 0.9993. All right. Is this my tail area? No. How do I know it's not my tail area? Because it's greater than 1/2. And if I were to draw a picture like this, we know that 3.2 is over here, and I'm always shading the area to the left. Okay? What I want is the area to the right. This is what I want. So now I have to do 1 minus 0.9993. Okay? So I get the area, and it's bigger than 0.5. So I know that's not my tail. So I know that my tail area is equal to 1 minus 0.993. So I get 0.0007. And now, is my p-value 0.0007? Yes, I have to double it, okay? Because my alternative hypothesis has a not equal sign. So the p-value is double my tail area. So p-value is equal to the tail area times 2. So my p-value is equal to 0.0014. All right, so what is the conclusion I make? My p-value is 0.0014. I don't have alpha listed, so if you don't have alpha listed, assume it's 5%. Is my p-value bigger or smaller than alpha? Smaller than alpha. So that means we reject the null hypothesis. And we say we have evidence that the police and fire departments have different proportions of minority employees. And lastly, in the context of this problem, what does it mean to commit a type 1 error? So type 1 error is rejecting the null when we shouldn't have. So what does it mean here? So in this case, it means the null hypothesis is true. It means that both departments actually have the same number or same proportion of minority employees. Actually have the same proportion. I'm running out of space here. Of minority employees. But we conclude otherwise. Sorry, that's all squished in there. But that's what a type 1 error would be in this context. It means the null hypothesis is true, but we believe something else. Questions, issues? Keep going. All right, number 40 through 44. Potatoes are sold in the grocery store in 5-pound bags. You decide to weigh a random selection of 10 different bags, and you find the average. Is anybody else curious? I always wonder about this. Like, you buy the sack of potatoes, and you're like, "There's no way it's exactly this." So, you know. And it always, they always exactly. So what I'm saying. All right. Well, they always err on the side of giving you too many potatoes. They don't want a class action lawsuit. You cheated me out of 1/10 of a pound of a potato or something. So they say 5 pounds, but they always give you a little bit more. So you find that the average weight of these bags is 5.2 pounds with a standard deviation of 0.3. Is this evidence that the bags at the grocery store have a mean weight different from 5 pounds? Okay, we're going to do a confidence interval here. All right, means or proportions, one sample or two? Means. Okay, and one sample, and we're going to do a confidence interval. All right, so let's list off the data that we have. What is our sample size? 10 bags of potatoes. What is our sample mean? 5.2 pounds. And our standard deviation? 0.3. All right, so number 40, how many degrees of freedom do we have? 9. That was easy. 41, what is the center of our interval? Okay, x bar, 5.2. All right, this one's the easy one, huh? If you're not sure about these things, you can always go to the study guide. And then you go, well, okay. What's the center? I'm dealing with one sample mean, so that's x bar. And what do I do? Okay. Standard error, okay? That's going to be s over the square root of n. So, oops. So I'm going to do 0.3 divided by the square root of 10. 0.3 over the square root of 10. And I get 0.0949. (43) says make your confidence interval. Okay, so I'm going to have in the center 5.2 plus or minus t star times the standard error 0.0949. All right, well, let's figure out our t star. T star, we have 9 degrees of freedom, and we're making a 95% confidence interval, so I go to the reference table. 95% confidence, 9 degrees of freedom, the number I'm using, 2.262. So I have 5.2 plus or minus 2.262 times 0.0949. Okay, so now I have 5.2 plus or minus 0.215. And that gives me 4.985 to 5.415. (44) What conclusion do you make? Meaning, going back to the question, is this evidence that the bags at the grocery store have a mean weight different from 5 pounds? Is the mean weight different from 5 pounds? Maybe, maybe not. Okay, well, so 5 pounds is in our interval. So we do not have evidence that the mean weight is different.
Is that 5 pounds or 5.2 pounds?
5. Okay, so because 5.2 is the center of our interval, so that's always going to be in your interval. Your sample mean will always be inside the interval. The question is the other number that you're looking for, is that in the interval? And in this case, 5 is in the interval, so we don't have evidence that it's different from 5. Does it mean that 5 is the mean weight? No, it doesn't mean that the mean weight is 5. It just means after looking at 10 bags, that's not enough to come to a conclusion. Maybe if we looked at 100 bags, then we would have a better idea. But looking at 10 bags alone, it's not enough for us to say the mean weight is different. We are almost done. It's the last page.
Mr. Chen?
Yes.
So for proportions, it's always z-tables?
Yeah, proportions is always z-tables.
And what about for t-tables?
Huh?
What about for t-tables?
the means. Whenever you're dealing with means, it will always be with the t-table. Proportions will always use the z-table. Means will always use the t-table. That's written in the study guide. What's that? Okay.
We just retype your study guide and just bring that.
You can just take my study guide and use that if you want. That's totally fine. Okay, again, you're allowed one sheet of paper, front and back. If you want to use my study guide, that's fine. And then if you want to fill in, there's a little bit of space. You can take like a red pen or some other colored pen and write, so you can fill in extra things, whatever. Write your self-encouraging notes. Huh?
Can we make it smaller?
Yeah, you do whatever you want, right?
Bring magnifying
I don't know if I can let you bring in a magnifying glass, but whatever, I can. How am I supposed to control this? Okay, so yeah, if you want to shrink it, that's fine. Yeah, I saw, someone wrote like encouraging notes. They're like, "You studied, you can do this. Breathe, relax." And I thought, hey, that's true. There's no.
You're good enough.
You are, right? You are beautiful, And really, this is just a statistics class, right? I love it, and this is like my life and career. But the truth is, it's just one little piece in your journey of life, and it did cost $700. That's true. But even still,
You know the interest is on my credit card.
yeah, even still, life is much more than what we do academically and things of that. So, okay.
You gotta take into account the $700 too.
Life is more than $700, okay? So fear not, okay? It took me 8 years to get to this point in grad school, so I understand. Sometimes things take longer than you expect. Yes.
Quick question: the study guide, I don't know if I'm the only one, but when you download it, you can't edit it.
It's a PDF, and that's because
Can we change that so we can make it?
Well, all right. The reason why it's a PDF and not a Word document is because there's like the square root signs and the math symbols, and for that I use a program called Latex, and I don't think you want to learn LaTeX. I suppose I could post the LaTeX file, but it's not written in Word or a Word document. So, huh?
So you can't cut and paste it.
If you, this is this is Sketchpad or Sketchbook. I can show you LaTeX later. Yeah, nobody really cares. Huh? It's just a program, but it's like writing in HTML but for math. So, all right. Anyway, let's finish here. Fair die should land number 4 1/6 of the time. You roll 100 times and you count how many times it lands 4. It lands 4 number 20 times. Does this mean the die is not fair? Okay. Well, we've got one sample. I'm just being less interactive. I'm just going to go through this. Okay, one sample, proportions, hypothesis test, right? If we look at our data, we have a sample size of 100 rolls, and it landed the number 4 20 times, okay? 20 times 100 rolls. So that means our p hat is 0.2. our hypothesis, we want to know, is P equal to 1/6? Okay, one sample proportion, is P equal to 1/6 versus the alternative that P doesn't equal 1/6. Okay, because it says different right here. So we have a two-sided test. 46, what is the sample proportion? That's just P hat. And we see that is 0.2. 47, it says, what is the standard deviation of the sampling distribution? This is just a fancy way of saying what is the standard error. Okay, standard deviation of your sampling distribution, that's basically your standard error. Okay, so your standard error for a hypothesis test is P times 1 minus P over N. Okay, notice that there's no hats in this standard error. Right, and again, if you aren't sure, you can always check the study guide. It does have the correct reference there. There's no hats. So we're not using 0.2, we're using 1/6. Okay? So you can leave it in fraction form. You can do 1/6 times 1 minus 1/6 over 100 square root. Or if you want to turn it into decimal, it's also equivalent. 0.1667 times 1 minus 0.1667. Over 100. Okay. You go through that. The number you get, 0.03727 for your standard error. Test statistic is, okay, again, if you check the study guide, it'll say P hat minus P0 divided by the standard error. P hat is our sample proportion of 0.2 minus 1/6, which is what was in our null hypothesis. So I can leave it as 1/6, or I'm going to turn it into a decimal, 0.1667 divided by the standard error of 0.03727. I do that, I get a z-score of 0.89. The next thing I do, I go to my z-table and I look up 0.89. Okay. When we look this up, look up 0.89, the area that I get, area is 0.8944. Is this my tail area? No, we know it's not because it's over 0.5. So my tail area is equal to 1 minus 0.8944. And so my tail area is 0.1056. Oh, I'm sorry. I messed something up. I did. I look up 0.89 and I actually get a different value. Sorry about that. So if I look up 0.89, I get 0.8133. 0.8133. Area is 0.8133. Okay. But my tail area is not 0.8133. The tail is 1 minus 0.8133. Okay, and we know that 0.8133 is not the tail because it's over 0.5. So my tail area is 0.1867. All right. Is that my p-value? No, one more thing. I have to double it because I have a two-sided test. Okay, so two-tail test or two-sided test. So the p-value is equal to 2 times 0.1867. So my p-value is equal to 0.3734. All right. And so my p-value is bigger than 0.05. So that means what? We do not reject. We do not reject the null hypothesis. Because if our p-value is bigger than alpha, we don't reject the null. And that means we do not have evidence that the die lands on the number 4 at a rate different from 1/6. Yes?
How do we know it's two-sided again?
How do we know it's two-sided? Okay, so the question says, is it different? Different means we use a not equal sign. Not equal sign always means it's two-sided. Got it? Anything else?
Don't take it away.
Okay, don't take it away. I'll leave it.
Professor,
Yes.
would that be question 50 or is there only 49?
That was question 49 on the practice final, and then I've got like another 9 questions on the practice final here. Okay, we'll do them quickly here. Yes?
So if it's less than or greater than, it's one-sided?
Yes, less than or greater than is a one-sided test. Exactly.
And that's on the study guide.
Yes. All right. I'm going to...
Mr. Chen?
Yes.
On the exam, it's going to be pretty obvious to identify like standard error because like over here for number 47 it says standard deviation of your sampling distribution.
Yeah.
Like how would you know that's your standard error? Like how would you identify that on the study guide?
I just told you, so this is now a fair question. Okay, so you're right. In the study guide, I tried to keep everything concise so it all fits on one page. But I didn't say like you also have to know that the alternative definition of the standard error is the standard deviation of the sampling distribution. But
Now you know.
now you know. We did cover that back in chapter 7. That feels so long ago now, but yeah, that's there, and so that's why I put these things into the practice final so you're aware of what's expected of you. All right, so let's do these last remaining questions from the practice final here. So we'll do these sampling questions. Actually, let's see this. Okay. We'll just do all of this. All right. Okay, so this is identify the sampling methods. Okay, so we know that there are 4 sampling methods. Do you remember? Simple random sampling, stratified, clustered, and systematic. All right. So number 50, I'll read through this. Don't shout out your answer. MLB wishes to conduct a survey of its players. Instead of trying to create a list of all the players from all the teams, they decide to randomly select 4 of the 30 baseball teams, and they're going to survey all the players on those 4 selected teams. So what kind of sampling is this? All right. Go ahead and tell me.
SRS?
Cluster sampling. Okay? Because here we are not randomly selecting from all the players. The players are divided into teams, or which serve as our clusters, and we're randomly selecting the teams. We're randomly selecting clusters there. Number 51 says a company wants to survey its employees. The company takes its master list of everyone in the company and randomly selects 100 of them for the survey. So what kind of sampling is this? This one is simple random sampling, and the key here is we see master list, okay? Or a sampling frame. We see that there's a list of everyone that we can just use to pick people individually. All right, and number 52, a toll bridge wants to survey the drivers who use the bridge. Instead of trying to ask all the drivers, they decide to stop every 10th car that passes through for the driver's opinions. What kind of sampling is this? Systematic. Okay, so there will be 4 questions on the final about survey methods or sampling methods. In my opinion, these should be easy slam dunk questions where it's like you get 4 points easily. But if you struggle with any of this, now's the time to ask questions. Yes?
So, is it just going to be a random amount of each, or is it going to be one cluster, one SRS, one symmetric, and one?
I'm not going to answer that question, okay?
That's fair.
You're going to have to read the question and pick the correct answer. All right, and then I've got a few questions like this. This is like stuff from before the midterm. Non-calculation questions, just conceptual things. Okay, so of course these questions are not going to be used, but you can think of questions that are similar. All right, so a bar chart is used for what kind of data? What kind being, do we have numeric data or categorical data? Bar chart. Bar chart is for categorical. All right, so of course, that question is now not going to show up on the final, but maybe it's good to review the other display methods. So look up, histograms, dot plots, frequency tables, etc., etc., etc. See what kind of data do we use for each of those things. Right, histograms, dot plots, frequency tables. What else do we learn? Oh, box plots. Okay. Yeah, scatter plot. Sure. So what kind of data is used for each of these things? You should review that. Okay. 54. In a normal model, approximately what proportion of data is within 2 standard deviations of the mean?
68%.
This one is 95%, okay? Things you should check out, what about the other ones, right? Within 1 standard deviation?
68.
Within 3 standard deviations? All right, okay. Those are fair questions, all right? All right, the intercept in linear regression would be our predicted value for x when x has what value?
0.
Yeah, when x is 0. That is our intercept. Okay? So also know what? Slope. Also know the meaning of correlation. You don't have to worry about all of the computational sides, but you got to know these concepts. Okay, if the probability of A and B happening together is 0, then that means A and B are, and I'm looking for a word here, yeah, mutually exclusive. So know what it means for independence. What does it mean for A and B to be independent? Okay. All right, for quantitative or numeric data, if there is only one peak in the histogram, how would we describe the shape of the distribution? Unimodal. Okay, and what else do we use to describe shapes? Bimodal, multimodal, okay. And we also have symmetric, left and right skewed, right? Left skew, right skew. Okay. So how would you describe symmetric? Symmetric means that values above the mean are equally common as values below the mean. Right? Yes. I'm not asking for your verification. Maybe just your assent. Okay, and which measure of center is not heavily influenced by extreme outliers? The median, okay. So that's like a little tidbit to know about the median. Maybe you should know other tidbits about the median or the mean, or other things like the IQR or the standard deviation, things like that. Okay, so know the definitions. Just like know the definitions and their significance and meanings here. Okay. So yeah, what does the standard deviation do? No, that's a z-score. Standard deviation is a measure of spread. Standard deviation is the typical distance from the mean. What's the IQR? It's the distance between the quartiles, Q3 and Q1. Okay? So anyway, we did the entire practice final review, which had 58 questions within our class time, along with a break. So I think you've got plenty of time to do the final exam. So we'll see you guys next week. Good luck as you study.